Welcome to the Trident Analyst tutorial on creating local layers. In this tutorial, I will demonstrate how to create local layers, define a layer's attributes, edit a layer's form and create domains and drop-down lists, create a relation between geometry and data layers, save a project as an inventory file, and how to load an inventory file. With your project open in Trident Analyst, click Add from the GIS panel. In the Select a Data Source list, select No Data Source to create a local layer. Note that a local layer is meant for small projects or for performing tests. Click Next. Type the names of the layers and select the vector type associated with each of them. For example, I am creating a layer structure to complete an inventory for poles, pavement lines, and signs. I will first create a layer called Pole. This will be a point layer. The next layer I'll create is called Pavement Line. This can be either a polyline or pavement line layer. Either type will be fine. My last layer is called Sign, and this will be a data layer. I will select No Vector because I will relate all my signs to each pole's location. Next, choose a color for each layer. Notice that the sign layer is not listed here because it is a data layer with descriptive information only. You will not see it in the video or the map. Click Next and then Finish. The layers appear in the GIS tab. You can always click on Properties and change these properties after they are created. If you wish to assign attributes or survey codes, you must first define these by adding fields to each of the layers in your project. This is commonly referred as creating a data dictionary. When you add fields, you specify the information that is going to be saved. The format of the fields you need to add depends on the type of information you need for each layer. This information can be quantitative data, such as height and width measurements, or qualitative, such as material types or object colors. In this example, I will add fields to my pole layer. With the layer selected, click on Data Model. The Layer Attributes dialog appears and displays the field associated with the layer. Click Add Field. Enter a name for the new field. For my pole layer, I would like to know the height of the pole, so I will add a field for height. The height will be a number, so select this from the list. Then you can define the values for height, whether the height measurement can be expressed in integers or real numbers, and how many decimal places. I would also like to know what type of material the poles are made of, so I'll add another field called Material. This will be a text type. Next, I will add a field called Date. Under Date, you can choose Now, which is the date when the asset was extracted, or Fixed, Editable, or GPS Date. I will choose Now to show the date the asset was logged. Click OK. You can customize your data entry forms and add drop-down items and domains for what the end user will choose when assigning the attribute data to each feature. This decreases the chance of resulting in data entry errors. With your layer selected, click Edit Form. The Layer Form Editor will appear for the layer you selected. Scroll down on the available fields list to find the fields you added, select them, and then click the right arrow button to add it to the layer form. You can change the order up or down if you like. Next, enter the options you want available in the Choices and Values fields. Use the Choices field to describe the option, such as metal, wood, and cement, for poles materials. Use the Values field to add a corresponding index number for the value if desired. Do the same for the other layers. For measurement fields, enter the specific preset codes to have the software enable the measurement function when the attribute is being logged. For height fields, enter DZ, which measures a distance in the Z-axis. For width fields, enter DXY, which measures a distance in the XY plane. When finished, click OK to exit the Layer Form Editor. When you have more than one object in the same location, such as poles with one or more signs on them, or poles with a sign and a traffic light, the software supports the ability to create a data layer that links these objects together and assigns them to one common geospatial location. Without relations, connected features such as a post, a sign, and a light will be positioned as single features. But with relations, you can define all of the features together in a single form. The decision on how you will treat these features ultimately depends on the method in which the assets are managed. To create a data layer for relations, Select your data layer, then click Relation. The Layer Relations dialog appears. You can create single or multiple relations. For my sign data layer, I will relate the sign with the light pole and with the normal pole. Then select the specific fields to relate the layers with. Click OK. Now, the signs on the poles and the light pole are linked together. With a local layer, you must save your work as an inventory file. An inventory contains the layers that define the features to be extracted. By saving as an inventory file, you save the layer as a template to use for other projects and can distribute the file to others to use. To save as an inventory file, click Save As from the GIS panel. Enter a file name and click Save. If you want to load the inventory file to use as a template later, click Open. That's it for this tutorial on creating local layers. See the next video in the series to learn about creating external layers.